Welcome to today's video where we will be discussing how to calculate and evaluate a heat distribution map in Microsoft Excel. So let's jump right in. Okay, so for today's video we'll be talking about how to design a heat map. So for this example, I've already drawn up this very good quality stainless steel sheet metal. So we've got a certain length and a certain width and some outside temperatures working its way onto this sheet metal. So I've drawn up this before the video, otherwise you guys would have been wasting 30 seconds of your life sitting watching me draw this. So for this example we need some parameters. So I've already filled in some of the temperatures. So for the maximum temperature, we're going to be working with 180. This will be degrees Celsius. I'll just do it like that. The minimum temperature we're going to take as 5 degrees Celsius. And for the length of this sheet or this plate, we are going to work with 4. This will be meters, width will be 2 meters. I know this isn't the correct dimensions and it doesn't look like these dimensions, but it's just for an example. So the delta x and delta y components of this is effectively going to be if we draw a grid over this stainless steel plate. So if I go, for instance, and this is just stating some obvious things, I draw this grid over this plate. So there are a couple of nodes where these lines intersect. So again, this is not accurate. Please don't quote me on this, but I mean, this is just for an illustration. So on these nodes, we can have a point where we measure the temperature on the surface of this metal sheet. So if we draw a grid over the sheet, this delta x and delta y is effectively what are the spacings between the nodes that we will have. So this isn't really accurate. I'm just going to remove that. So for this example, we'll be looking at a 0.2 meter spacing on both sides. So this will impact your grid across the steel plate. So for the rows, this is now the grid size. I'll be working with, let's take, so the rows will be the width divided by the delta y, and the columns will be the length divided by the delta x. So again, this is just a simple example. This can be anything. If you decrease the size of your delta x and delta y, the smaller your grid is going to be, therefore the more rows and the more columns you'll have. So it will be a much more accurate representation of the heat map. But again, this is only for your example. You can play around with this. The beauty of this is that you can just create your own example, follow along, create it, and just play around with it and see what happens. And the inverse is, if you enlarge these delta x and delta y, the further your nodes are from each other, the larger your grid becomes, the more inaccurate your heat map will be. But for this example, this will work perfectly. So now I'm just going to draw a simple, just a grid. So there's 20, we're just going to go 22 and we're going to do 12. Explain that to you now. Okay, I'm just going to draw this grid there. So we've got our grid. And now, so effectively, this is the plate that you guys can see here. So if I just do that, you'll see your plate, the stainless steel plate that's illustrated there. So these outsides will be the outside temperature that is taking an effect on our plate. So here we'll have the minimum temperature. We just wanna lock this up so that we can autofill this. Just do that. Just filling in the minimum requirements, as you can see from our little picture here. So the maximum will then be 180. Also just gonna lock that. So fill all the way through. So this is our first off representation of our steel plate. So we've got our grid and we've got our nodes. Obviously these aren't scale accurate, but this is accurate according to what we've done up here. So to get these values, to start with these values, it's fairly simple. So in the formula bar, we are going to say equals, then we are going to put in brackets, we are going to take the sum of all the external cells that have an effect on our cell or our node. So we've got 4 cells touching, and we are going to divide that by 4 then. So you can see this formula we're going to use here will reference each other. So if I autofill this, you'll see the values change. And if I take this across, you'll see all the values change. So there we have our temperature distribution over our steel plate. So it's fairly simple. You can pause and rewind if you missed something, but it's really, really simple, guys. And for the distribution now, just to indicate it, you can just highlight all your text, all your selected values, or your selected your steel plate. We can head over to the styles section on the ribbon. We can go to conditional formatting, click on the color scales, and here are a couple of options. So obviously our minimum temperature can't be red, and our maximum green, depends on how you feel about it, but you can just play around. There are a lot of options here depending on your distribution map and what you want to show other people. You can do this. This looks pretty much the same. So here you can actually just see the distribution, your heat distribution, as we go along. This actually isn't maybe the best one. Let's just go over to this one. This indicates a bit better. You can see a bit better coloration on the cells, and this is actually a very true calculated way of a heat distribution map over a steel plate. So I hope you enjoyed this video, and I hope it was very useful and helpful to you. If you enjoyed it, please like the video and subscribe to our channel. We will love to have you on board. And please comment down below more Excel videos that you would want to see, or even your own specific problems that you are struggling with, and we will try and make a video for you. Thank you so much for watching, guys. Enjoy the rest of your day. Until next time. Cheers.